Okay, so for lesson 3, we're finding the epicenter of an earthquake. And in order to do so, we're going to use triangulation. Triangulation is a method used to pinpoint the epicenter of an earthquake using data from seismographs in 3 cities. Now, there's a reason we have to use 3 cities, because 1 is not enough. The epicenter is the location at the surface where earthquakes occur. So the focus is the part based upon depth underground. The epicenter is at the surface. So if I only use 1 city, basically I'm going to have a distance from that city, kind of like you see up here. Phoenix at 795 kilometers from that city. So I can figure out 795 kilometers from Phoenix, and then I would draw a circle, and excuse the fact that that's not going to be a perfect circle. And basically, if Phoenix is in the middle, that means my earthquake is going to be somewhere on that circle around it. But we can't spend all of our time trying to figure out where that earthquake is. So we take a different location, and we get the distance from that, and we would then draw a circle around that one. Whoop, that is definitely not centered. Okay, so our center of the circle would have to be like here. That narrows it down to 2 locations where the earthquake could be. Both of these places where the circle intersects, the 2 circles intersect. So then we need to have 1 more location, and then we would have whatever distance around that circle. Please excuse my terrible drawing. And then that would tell us that our earthquake would have to be right here. Now, you might not always be perfect with your lineup of where your earthquake occurs, but the closest location where those 3 circles come to intersecting is what we'd be looking for as far as our location. Now, when you're doing your homework, I want you to put like a star in the location as to which spot that the epicenter would be. The earthquakes can occur anywhere along the radius of the distance, so that's why we draw that circle this distance away. This creates a circle around each seismograph location. Where all 3 circles intersect is the epicenter, and then compasses can be used to create the possible locations from each city. I will have compasses available for you to use in class. The next part is going to go over actually doing the epicenter for this activity. So you'll put that right in your notes. Okay, so we're going to do our first practice with finding the epicenter. You're going to need a compass, and then you have your scale at the bottom. We have our distances up top. So we're going to end up with 3 circles. We need from Phoenix, the earthquake is 795 kilometers away. So I'm going to come down here, measure 795. Here's my 800 mark. So we're going to be just shy of that. Okay, I'm going to put my point on Phoenix, which is in Arizona. And the easiest way I've ever done this is just to put the pencil down and spin the paper. It tends to work better. If you do spin the compass, it's possible that it'll get off. It might not work the best. All right, so there's my circle for Phoenix. Then I'm going to go ahead and measure out 1110, which will be just past the 1100 mark. And that's going to be from Denver. So I'm going to mark Denver, Colorado. Spin my paper again. And yours is slightly smaller scale because it's set up in your notes. But either way, everything is proportional. So you'll just have the smaller paper. Okay, and then we've got Olympia, which is 750. So we're going to go just under the 800, halfway between the 7 and 800. And I want Olympia, which is up here in Washington. Oh, the other thing I want to point out. So right now, the earthquake either has to be here or here. Well, if I come to Olympia and I do my 750 kilometers from there, make our 3rd circle, and our earthquake is going to, we see this little triangle here, Now, it's not exact, but I can definitely tell that Sacramento is the location of my earthquake. Okay, so this is the gist of it based upon distance. Okay, so earthquake wave travel time. You will be seeing this graph. We're also going to be using this data from this graph to make another graph later in the unit. But this has our P wave, which is the lower one because that's the one that arrives first, so it doesn't take as long to travel the distances. Then we have our S wave. Now the other things we have on here is travel time and in minutes, how long it takes to go a certain distance, and then epicenter distance, which is in thousands of kilometers. So keep in mind that this label you have to times by 10 to the third, which means you're getting into the thousands for each of these values over here. So this graph can help us determine the time it takes for a certain distance of traveling. It can also determine the distance it takes based on a certain time. So we can read this graph both ways. And it can also determine how far away an earthquake is based on P wave and S wave arrival times. So if we know that there's a certain amount of time between the waves, that's something I'll go through with you later too. We'll go more in depth with that, but I'm going to go ahead and switch over to this other one. So if we want to use this graph, how far will a P wave travel in 6 minutes? So we want to follow the P wave. We want to find 6 minutes. We're going to come over to the P wave, and we're looking at about 3,200 because each of these down here is worth 2, 4, 6, 8, 10. So each of these is worth 200 kilometers. So 3,200 kilometers is what I would be looking at. But this is going to break it down. We're looking for the 6. We're following the line over the P wave. And that has us going a little further than the 3,200. Accuracy is going to have an impact on how well your circles work when you're doing this stuff. And just be as accurate as you possibly can. So this has us saying 3,250 kilometers. All right, next one. How far will an S wave travel in 17 minutes? So we're going to find our 17. We want our S wave, so we're coming over here. And then we're going to go down from that point, and we're looking at 6,000 kilometers. Okay, how long does it take a P wave to travel 4,000 kilometers? So we're going to find our 4,000, which is here. We're going to go up to our P wave to this point, and we're going over, and it looks like about 7 minutes. Now, how long does it take an S wave to travel 6,400 kilometers? So we need to find our 6,400, which is this line. Go up to our S wave to this point. Follow it across. We are between, let's see here, each of these is 20 seconds, so 1720, 1740. We're about halfway between 1740 and 1800. So 1745, if you said 1750, that'd be fine too. Just know that accuracy will impact how well your circles work out. Okay, so these practice questions I have you working on for one of the activities for this unit. So you will see these later.